video is a concept called cost-benefit analysis. And I'm not going to spend a lot of time talking about it. It's very straightforward. You're going to read a paper about one of the issues related to cost-benefit analysis. And we're going to talk about, of course, talk about this in class a little bit next time we meet as well. But I just want to kind of go through it. What we're going to talk about next week is this concept called non-market valuation, and it's all about how we ascertain the value of environmental amenities so that we know what environmental damage is. We can kind of know that pollution is existing in the abstract, but what we really want to know is what are the problems that pollution is actually causing? What is the actual damage that's being caused by pollution. In order to do that, we actually need to quantify the environmental damage. This, of course, underlies the concept of negative externalities. When we talk about marginal external damage, we're suggesting that we can measure it. We're suggesting that we know what it is, and then we can set policy appropriately to deal with that. And so it's really important for us to have quantitative understanding of these issues. One of the most simple ways for us to compare environmental policy with the status quo is for us to conduct benefit-cost analysis or cost-benefit analysis. And benefit-cost analysis is super straightforward. And in simplest form here, you can see that we want benefits to be greater than costs, with both of those numbers being monetarily defined. So again, we don't merely want to talk about pollution in terms of how much emissions there are, but we also want to have an idea of what that pollution does in terms of damage so that we can understand whether the benefits of reducing the pollution are worth a particular cost to reduce them. The issue with benefit cost analysis is that money has what we call time value. And what I mean by time value is that $1 today is not worth $1 tomorrow in terms of purchasing power, meaning that over time the value of money fluctuates. But more than that, that's one particular reason why time value has money. But more than that, money has time value because I can invest it. In other words, the reason why $1 today is not worth $1 tomorrow is that if you gave me $1 today, I could invest it. And in a year from now, I could actually have more than $1's worth of value that originated from that first dollar. In other words, whenever we're comparing different investment choices, which is when we're deciding whether we want to engage in environmental policy to reduce environmental damage, we're making an investment. Environmental policy to reduce environmental damage creates cost. That cost can be considered an investment, and the resulting reduction in environmental damage, the benefit. And so it becomes actually very easy for us now to consider whether the costs of a particular environmental policy are worth the benefits that would arise from that particular environmental policy. Of course, assuming that we can quantify the benefits, that is the reduction in environmental damage, relative to the costs. So we need to be able to do that. That's sort of a first off. We need to be able to measure the benefits of reducing environmental damage. Again, this is something that we're going to talk about next week. But for right now, let's just assume that we can do this. Time value of money matters because if I'm going to invest in something today for which I will receive benefits in the future, then I cannot compare today's cost with perceived future benefit because they exist in different time periods. I can't compare $1 today with $1 tomorrow because they're fundamentally different. Therefore, I cannot compare benefits today with costs tomorrow or costs today with benefits tomorrow, which is most often the case. Normally with environmental policy, there is cost today and the benefits are experienced over time. And so we need to take this into consideration. This equation here is known as net present value, NPV, net present value. The net refers to the fact that we're subtracting costs from benefits, so we have benefits and costs. The subscripts here refer to time periods, so this is 0, kind of an initial time period. You can think about it as being today, and then sort of 1 year from today, 2 years from today, 3 years from today, so on and so forth. And so the idea is that I'm going to experience costs from environmental policy. It's usually in this initial period and maybe afterwards, and I'm going to experience benefits from this policy, not likely in this first period, most likely afterwards, but then after the policy I could actually experience benefits in multiple periods. The actual time value of money calculation is very simple in terms of Excel, and I'll actually show you how to do this in Excel here in just a moment. But for right now, let's just kind of stick with the equation. So net present value, the subscripts refer to the time periods, and then the other important component is what we call discounting. So if we look here at the numerator, or excuse me, the denominator, we can see that we have 1 plus R. R is the discount rate, or essentially the interest rate that we're assuming. And the reason why we do this is, again, I'm going to experience this money, benefits minus cost. I'm going to experience this 1 year from today. So what I want to do is I want to implicitly compare it to money that I simply could have invested and earned an interest rate R. So I have to discount this money back to the present using that same interest rate. Basically what it means is that because I'm not going to actually earn this money until next year, I cannot compare it to money that I have or that I'm going to spend, the cost of the project in the current time period. So I have to discount the value back to the present. And as you can see, the further I get away from the present, the greater that discount factor is. In fact, you can see that it increases exponentially. And so, again, the idea is that if I need to compare future money to current, I want to calculate a net present value calculation in order to do this. So let's bring up an Excel spreadsheet here. It always asks me that. I always say yes, and then every time it tells me that I have to go change it somewhere else, and so I never do. All right, so I'm just going to make up some data here. So let's just assume that we have project A, and then what we'll do is we'll think about this in the context of project A having costs and benefits. And then what we're going to do is we're going to say year 0, so that's sort of the current time period, year 1, year 2, year 3. Let's do 4 years. All right. Let's assume that the project has costs of $10,000 in the first year, and then has 0 costs every year. So let's imagine that this is a project that just cost us $10,000 in the first year, but doesn't cost us anything after that. So it's just a one-time cost project, which is actually a lot of projects. And then let's assume that we experience 0 benefits in that first year, but then beginning in the second year, we start to experience $3,000 worth of benefits. And we'll just do that. All right. So here's how we think about it. So in the first year, we had $10,000 in costs, no benefits, and then in every subsequent year, we have 0 costs and $3,000 worth of benefits. And then what we can do is we can net these. We'll say net benefits. And then we'll just do this minus, oops, minus this. And then we'll just do that here. Voila. All right. So now what we can do is we can calculate net present value. So I just go to an empty block. I put it in equal sign. This brings up the function parameters for Excel. And then I just do MPV. You'll see that MPV is right there. I just double click this. Now the way that MPV works is that I need to have sort of all of my various components. So what I need to do before I do this is I need to assume a discount rate. So let's just assume a discount rate of 4%, so 0.04. So we're assuming a discount rate of 4%, which is very common. All right. So go back to MPV. I'm just going to retype this in. MPV. All right. So the first number is the discount rate. You'll notice it says rate right here. So I'm just going to click the rate, comma. And then the first value is you want it to be the net benefits. And you want it to be the net benefit in that first time period. So put that in. So B4, which is negative $10,000. And then comma, and then value 2, comma, value 3, comma, value 4, comma, value 5. And then just close with a parenthesis, hit enter, boom. And what we find is that after 4 years, the net present value of this particular project is $855.47. What that means is that if I were to move forward with this project, my expectation is that after 4 years, I will have made essentially $855 in benefit above costs, taking time value of money into consideration. Now let's just look at this and compare this with if we were to not consider time value of money. So if we were to simply take the $10,000 and we were to then add all the various $3,000 to it, hit enter. And what you'll see is that the non-time value of money considered net benefit is $2,000, considerably higher than the net present value we calculated. So again, you can see how important it is to discount future earnings of money when we're considering cost-benefit analysis. And again, this could be a project, you have one in your problem set that you'll have to complete, and it's very straightforward and very simple. But the thing about benefit cost analysis is that it's used everywhere. I mean, I use benefit cost analysis for several research projects. Benefit cost analysis is really ubiquitous. You'll read in one of the readings this week about one of the problems with cost-benefit analysis, and there are some various pitfalls of benefit cost analysis. One, the choosing of the discount rate really matters. In fact, we could change the discount rate. Let's change it to 20% as opposed to 4%. And we can see that when we do that, it in fact causes the net present value to go negative. We didn't change any of the underlying dollar amounts or anything. All we did was we changed the discount rate from 4% to 20%, and we can see that now, in fact, this project doesn't look good anymore. It looks like we're going to lose money on it. I can then pick a discount rate 0.0001 if I wanted to. And of course, when I do that, I would see that it's in fact now a good project again. Anytime you have a mechanism that is this easily, manipulated, this is problematic. So one of the biggest problems with cost-benefit analysis, I can put it here. One of the biggest problems with cost-benefit analysis is So one of the biggest problems with benefit cost analysis is that it's very sensitive to the discount rate selection. It's also sensitive to the number of years that you consider. Oftentimes you don't actually know how often into the future or how far off into the future, rather, you're going to gain benefit from something. Sometimes we miscalculate, what the benefits are actually going to be. And so all of these various things tend to be very problematic. And so it's something that we want to consider. But still, at the same time, cost-benefit analysis becomes really a very efficient way for us to consider whether a particular environmental policy is worth it, assuming that that environmental policy comes with cost and future benefits. We can use net present value to consider the time value of money. Usually we pick discount rates around 4 to 5%, so this would actually be a typical cost-benefit analysis using this particular data. All right, so aside from what I just mentioned about not really knowing sometimes about whether the cost and benefits that you assume are actually going to occur, there's always some uncertainty there. Benefit cost analysis has additional weaknesses. I mentioned the discount factor matters. Payback time should matter as well. In other words, how quickly a project pays for itself tends to matter, although that can cause folks to override what are potentially good or bad projects by focusing too much on how quickly they pay back themselves. This may cause us to reject good projects when we otherwise shouldn't. And this also brings up a Paul Samuelson quote. Paul Samuelson's one of my favorite economists, sort of the godfather of public goods. He said once that a good cause is worth some inefficiency. And what he meant there is that sometimes projects like environmental policy that would reduce environmental damage may do so at the expense perhaps of some economic efficiency. But it may be worth it, right? That in fact, maybe it's okay to give up some economic efficiency if we're reducing environmental damage. And, it's sometimes we get a little caught up maybe in the cost-benefit world and making sure that everything is monetarily worth it, when deep down inside we know that, regardless of whether this makes sense monetarily, it's probably something we should just do. This is something that comes up, and it becomes a real existential struggle for environmental policy, and it's something that, we want to pay attention to. We want to think about it. It's one of those big-ticket items that I think a lot about, and that really affects how I approach my research, affects the way that I think about environmental policy. And then lastly, and this kind of leads us into what will be the discussion for next week, is, how do we actually monetize environmental benefits? How do we actually think about them in the context of them having a cost associated with them? And that's difficult to do, but that, again, will be the main thrust of what we talk about next week. This Uncertainty and the Evaluation of Public Investment Decisions by Erwin. And again, it's a paper that I've mentioned a couple times so far. This will be one of the papers that you read for class on Monday. Make sure you do read it. It's a paper that talks about a lot of these particular issues, and mostly talks about what happens when we have uncertainty about benefits and costs, and what that might do to our analysis in terms of cost-benefit analysis.